Today, our team will be presenting on our model leaderboard and evaluation automation platform as a part of our AI Studio final project with Anote AI. So just a quick introduction of our team. We have Lynn from Florida State University, Kalina from Northeastern University, myself, Michelle from Swarthmore College, Stella from Hofstra University, Jeremy from University of Virginia, and Ashley from Johns Hopkins. And then throughout the semester, we would also like to thank our AI Studio coaches and challenge advisors who helped us through our problems. So we had Abhishek as our AI Studio coach and Rashri and Natan as our Anote challenge advisors. So before we dive in, this is the roadmap for today's presentation. We'll first go through our project overview and then as well as our goals, approaches, and impacts, along with what we did for data preparation, our modeling and evaluation, and then finish up with some final thoughts and time for Q&A. So first is our project overview. So the main problem that we're trying to address with our project is the difficulty that comes with evaluating machine learning models. While it works fine for simple models like logistic and linear regressions, more modern machine learning tasks like image classification and translation are not as straightforward. And there's different data sets, pre-processing, metrics, and setups that make results inconsistent. And within industry, each domain-specific use case can have a different and tailored evaluation metric to determine the success of these models. Next, while there is currently an Anote AI leaderboard platform, its current process to submit models or data sets can be quite slow because it's being done manually through a Google form. And this causes a limiting of participations as users have to wait 1 to 2 days to actually see their rankings on the leaderboard. And with that, our final problem is that if people do want to end up submitting multiple models and data sets at a time, the manual process would be extremely difficult to scale. So then our solution and goal of the project is to develop a centralized and reliable platform model that would compare large language models across different tasks. So we would try to implement backend APIs to accept model fields, data sets, and predictions. And then we would automate an evaluation scoring and result storage and connect the backend with the front end leaderboard for live updates. So just a summary, the project develops a public AI API for Anote model leaderboard to quickly add new data sets and model submissions across all task types, forming a scalable, transparent platform supporting tasks like text classification, named entity recognition, and document level Q&A. And then as for our business impact, this would help with automation, would increase speed, accuracy, and scalability. The companies will also have a centralized area in which they can have fair model comparisons, and they will also have a way to try to prevent metric gaming for the leaderboard rather than performance, because there will be a hidden measure in which the models will also be evaluated against. And then our approach was a 3-step milestone process, which we set up the backend API in the first month and just have initial leaderboard displays. We then also automated the evaluation pipeline and connect the backend to the front end for real-time updates in the second time. And then finally, in the last month, we expanded to multiple data sets and finalized integration and deployed public leaderboard.
But that's better than that.
Yes.
And then the resources that we used were Flask for building the API endpoints in Python. And then for the front end, we used React with Vite and Tailwind CSS. And then by using SQL Alchemy and PostgreSQL, we were able to build a database. And then ultimately, we deployed with Vercel and Relay.
Yeah, so for the data preparation, as for the data sets we use, we leveraged open source labeled data sets from every task domain for like our NLP models. And most of these models were found on HuggingFace. So like for text classification, we can use IMDb reviews for sentiment analysis. And for like image classification, we can use CFAR10 or FloodNet, which are pretty state-of-the-art data sets to evaluate NLP models against. And for multimodal like captioning or visual Q&A, we can use Coco captions. And for all of these data sets, once we pull them from HuggingFace, we would have like a list like of questions and ground truth answers. So we would, for most of these data sets are already like filtered, but we can just do a little bit more manual cleaning and filtering of noisy or duplicate data along with like sensitive or personal information. And then it would split all of these data sets into a public set, which we send to the users to evaluate their LLM on. And we also would have a hidden evaluation set. And as for the evaluation metrics, we use a state-of-the-art, like well-known evaluation metrics for each individual task type. So for name entity recognition, people typically use precision recall F1. And for classification, people typically use accuracy and captioning, but we also added our own evaluation metrics to kind of separate us from other leaderboards. And the metrics we add kind of emphasize robustness, bias, consistency, calibration, and efficiency to give the users a better understanding of how well their LLM is performing on our dataset domains and task types. So as for the modeling and evaluation portion, I think Lynn can talk about this part. Or actually, I can talk about it. So for the evaluation pipeline, every single submission we get, we prompt the users with our questions for the specific task type and data set as a JSON file. And then they would also see like the output structure, and they would prompt that to their LLM. And once their LLM gives a JSON response, we would ask them to like manually submit it to our API. And then once our API receives this data, it correlates it to its correct like backend file. So like which class for the data set and task, and then it runs like similarity rankings and evaluations against our ground truth data, which is hidden from the users in our backend databases. And then out we get all of our evaluation metrics put against the leaderboard in the front end UI. And from here, other users could view the LLM's ranking on the leaderboard, along with like where it places against state-of-the-art models like Gemini or GPT. So here's an example of what a leaderboard would look like. So for the AG News data set on the text classification task, you see that GPT-4o has a score of 0.94, which is the best out of all of the models that have currently been submitted to this task type. And I can actually give a demo. So we deployed this, the front end on Vercel and the back end and database on Railway. So here you can see all of our LLM leaderboards. So we have text classification, name entity recognition, document Q&A, line Q&A, and retrieval. And there's also more like sophisticated domain benchmarks. So safety and alignment, like how well an AI focuses on like benefiting humanity and won't like lie to us or break certain rules, along with like code generation. So how well an LLM can generate, say, web development code. So I'll walk the users through a pipeline of seeing how well their LLM performs on the AJ News dataset for the text classification task. So when we go to submit a model, I would select the task and the dataset, and then I would get the JSON file with questions and an ID associated with each question. And now I can prompt ChatGPT with the JSON file. I'll say, okay, I'll give it the format that I want the output to be in. I'll say, answer all of these questions for text classification and the output in the correct. Okay, so while this is running, what we want to see is if we go to our leaderboard for this specific task, we would want to see like how well the performance is compared to other state-of-the-art models. And we can also analyze like individual metrics So F1 score, and also we give the users like an idea of what each evaluation metric actually does. And we can also view the actual data set at HuggingFace. Right now that link is broken, but we would fix it. So I'll just make it answer quicker, so for the sake of the demo. But we also allow users to import other data sets from HuggingFace, and we would ask them to like clean the ground truth themselves, or just prompt it to us so we could fix it. Or they could also manually enter in a data set with all the questions and ground truth answers. And then once the users submit a model or a data set, they can view the total history of everyone that submitted to this model. Okay, so we got our JSON output, and I'll just place it here and load all of them. And then I'll give this model a name, so Anote demo. And then we can submit it. And then we see that our backend ran the computation and gave all of our metrics. And now if we refresh the leaderboard, we see that this model has been submitted. It's been given an overall score of 0.64, but we can also see all the eval metrics that it was compared against here. And I think overall this model placed like 16th place compared to all the other models. So it hasn't been performing as well as we would like it, but we can fine tune it later on and see its place in the leaderboard go up.
Okay, so we can go to like the very last part of this presentation where I will like go through our final thoughts, including like what we have learned throughout the semester, as well as like some of the potential next step if we have like more time. So first, going to like what we have learned throughout this project. So first, I think that like we learned that like supporting diverse task type and also multilingual benchmark requires a careful API extensibility and also design foresight, because at first like we have like a lot of like problem like structuring the code and stuff. So how to make it like scalable is also like, I think it's also like a very important question that we should like answer beforehand. And secondly, I would say that we also like demonstrate like how state of art like models perform on diverse tasks and like on the data sets as well. And thirdly, we learned that like benchmarking is really like important for responsible AI, because like with this metrics provided by benchmarking, we can like not only measure the strength, weakness, and also like task suitability, but we can also like know where to like improve on the models. And lastly, I would say that we learn a lot in terms of like technical skills, like how to build a fully operational evaluation pipeline implementing LLMs. And next, if we have like more time, then here are some of the potential next features or add-ons that we can do. Firstly, I think that like for now, it's just like display the matrix of the models like separately, but given that each model they have like updates from time to time, so I think it would be best if we can allow like have a feature which allow user to track model performance like over time. And secondly, I think that like we can also support custom metrics and also like ensemble like evaluation for flexible model like comparison. For now it's like default to like compare everything, but I think that sometimes people user want to like specify which metrics they want to just focusedly look at. And thirdly, it's just an add-on to like maybe we can have like authentication and also like API keys so that we can secure user and admin access just for like the sake of like authentication. And lastly, I would say that like more testing is never like a harm. So I think given more time, we can try to like add more models and also data set to like give the best results. And yeah, I think that's basically the last of our presentation. So if there is any question.
Thank you, guys. That is really impressive. Honestly, you should be really proud of this project. I think it looked really, really good and definitely is better than our existing leaderboard. So let me just try to recap it so I understand like exactly what you did, and let me know if I missed anything. So in our existing leaderboard, right, we have like different data sets, and you can view the data set and you can see how models will do, but it's kind of like hard coded where we would have a data set and we'd have that JSON. So what you implemented is like the API to submit the model and data set to the leaderboard for any given model or data set. And then this kind of ability to see like in real time how the results would be there. And then to kind of see like filter across different types of domains and data sets, right?
Yeah.
Was there something I missed there, or yeah?
No, that's pretty much what we did. Yeah. So there's already we already seeded our data set with like typical state-of-the-art models. So like Llama or like Claude Sonnet. And right now that's like synthetic data. As you said, it was hard-coded because I think for all the different domain and task types, like we would have to run inference on it, which is pretty computationally expensive. So like for the sake of the demo, it's just hard-coded.
Yeah, I see. So the results that were like GPT-4 or Llama, those weren't like from the model, but hard-coded. Okay. And then really what you did and what you're showing is that you can add a data set or a model to leaderboard, and then it will just kind of update and you can see how it will do.
Yeah.
I guess here's a random question for you. Did you think about like if somebody wants to have their own like data set that they'd want to benchmark similar to how you generated it synthetically, like maybe a way like, because I kind of agree with your point where you're kind of like sometimes people want their own custom benchmarks with their own custom metrics, but then also sometimes people want their own custom data set to do the benchmarking. I feel like that could be cool where you can be like, I want a data set about like race cars or something, you know?
Yeah. So I think for that, like for uploading a data set, we had kind of had it set up, but I didn't really test it. So like either you would use the HuggingFace like import and then split it into like a test and eval set and then like curate the ground truth values, or be able to also have your custom evaluation metrics, which you would need to like sort of make a function for or something to like fit our API.
And all your code is in this repo here.
Yeah.
Okay.
Yeah.
Interesting.
It's kind of dirty, but it could be cleaned up.
Yeah, for sure. And you guys created like a documentation guide for how to call the APIs too?
Yeah.
Okay. So did you enjoy like working on this project?
I think a lot of it was like SWE. So it was kind of not really in the expertise that most of us had. So it was like a learning experience.
Yeah, no, that makes sense. So it's kind of interesting. I guess I'll provide some context and like kind of why I think this is like a really interesting project. So kind of the way the industry in AI used to work, right? It was kind of like you would maybe want to train or fine tune a model, and you might need data to do that, and you would kind of get these like training or eval data sets to do that, and that would be like how you build your model. And without that kind of data set, you wouldn't be able to train a model. But now with LLMs and AI, Gen AI, you can just kind of call out like GPT or Claude to make inference on a bunch of different things, right? And these models are really good at a lot of tasks. And there's a lot of these like frontier AI labs, right? And a lot of these labs are trying to figure out like how do we take these models and help them do like the last mile, like how can we make it really good at science or math or coding or biology? And to do that, what these kind of labs will do is they'll normally get people who are like these SMEs of an area, and this kind of people will kind of go through and they'll provide this like labeled data on like here's these biology or healthcare questions and here's the answers, or here's all like the coding questions and here's the answers, and then you can use that to kind of train these like custom models for specific domains, or benchmark do like the benchmarking for these custom domains, right? And so a lot of these kind of frontier AI labs like OpenAI or Anthropic, they'll kind of pay lots of money to these teams of people that create these benchmarks as well as these data sets. It begs the question, right, of like how much of that data set benchmark creation and training data set curation for customized domains can be automated with like the help of really good synthetic data and benchmarks, versus how much of that do you really need a person in the loop who knows the expertise, right? And that's kind of where we see potential like business value, right? And kind of like on the frontiers of AI, it's kind of like there's three like areas, right? It's like the compute, the models, and the data. So really being able to get like this really high quality data is a huge pillar of advancement. So I think this leaderboard project did has like a lot of potential. And there is a bunch of like ML work to do if you wanted to make the actual data sets really good, right? Like if the goal was rather than just having the leaderboard, it's like how do we have the best data? I guess for you guys, is this something you would be interested in like further working on?
Like the leaderboard or
I
just
think
in general?
Oh.
Like which
Like,
aspect?
yeah.
Yeah, I guess you can have two answers. One could be like Anote stuff, particularly because we have like a lot of Anote work, and there's a bunch of projects. And two, it could be like the leaderboard project, maybe. And three, are any of you guys in New York City by any chance, or are you guys like all over? Or
I'm in like New Jersey area.
oh, wait, where in New Jersey?
I'm like near South Jersey, but like I go to New York for fun.
Okay, yeah.
I would say like I'm interested in like I think this was an interesting project because I actually never had like SWE experience before. So that's why I was like initially like really like overwhelmed because I think our program was like preparing us for like machine learning things. So this was kind of like a curveball, but I think the experience was interesting for us to like understand a little bit more in the background.
For me, I think that like most of my experience before is like relate to SWE thing. So I would say that like working on SWE is like also like interesting for me because I'm still working on it. But like I would be really interested if I can also like bring in the AML like the LM things into like the work as well because like I want to like continuously learning and also like yeah just to like develop some new skills like that.
Yeah, I am kind of in the same boat. I have like a little bit of SWE experience, so that definitely helped be familiar with all the tools we used. But this was a good start at kind of bridging the gap between like SWE and ML, and I would definitely be interested in exploring that further.
Yeah, I think like this project, I think like a better way to approach it would be to have some centralized way of like uploading model weights in like a specific format, so then you can actually run like real inference on it instead of just like comparing against the JSON file. And like there's also like room for improvement. Like instead of using LLMs, you can also like add other deep learning stuff like VLMs or like RAG or some other like video classification stuff. So I think there's like a lot of room for improvement.
Yeah, I agree. I feel like also just on like the actual data set side, right? This is kind of maybe even more like closely aligned with our synthetic data project, right? But like, how do you ensure that the data that's actually been used for the benchmarks is like really high quality, you know?